Hello everyone. Today we're going to talk about adding and subtracting rational expressions. So knowing a rational expression is a polynomial over a polynomial, we're going to talk real quick about adding and subtracting fractions. So we need to remember that we always have to have a common denominator in fractions. So in this first example we have a common denominator of 3. So we can just do the math with the numerators, which would be 5 minus 7 would be negative 2, and our common denominator will stay the same. Can't do any reducing, so that would be our final step. If we had fractions that were not having common denominators, we need to find the least common multiple. And so the least common multiple between these two would be 20. And so we can multiply 4 by 5. And whatever we do to the bottom, we have to also do to the top. And same thing to the right side, we can multiply by 4. So we'd end up with 15 over 20 plus 8 over 20, which would then give us 23 over 20 with no simplifying being allowed, so that would be our final answer. Okay, so we're going to step this up and talk about some rational expressions with this. So if we're looking at rational expressions, now we have multiple variables that we have to pay attention to. So for the first one, x plus 3 over x minus 1 plus x minus 2 over x minus 1, we have a common denominator of x minus 1. So we don't have to do anything with that. We can go ahead and add the numerators. So we're going to add like terms up top. So x and x will make 2x, making sure that we're adding, and then 3 and negative 2 will add to be positive 1. And our common denominator stays as x minus 1. Now we need to remember that we can only simplify this if we are able to factor or have a common factor. So 2x plus 1 has no factors other than 1. X minus 1 doesn't have a GCF of anything other than 1, so this would be our final answer, and we can't do any extra simplifying from there. Same thing for the next one. We have x plus 3 over 2x minus x minus 2 over 2x. So we have a common denominator here, but we want to make sure we distribute that negative. So you can talk about it like x minus x, or we can just go ahead and say x plus 3, and this is all going to be over 2x since we have a common denominator, and distribute the negative minus x and then plus 2. Combining like terms, we get x minus x is 0, and then 3 plus 2 is 5 over 2x. There's no simplifying. 5 and 2 are both prime, so we cannot simplify anything further. Okay, looking at the next one. So we have 4x over 2x plus 6 over 2x. If you already have a common denominator, you don't necessarily need to simplify. You could factor this before if you wanted, but it might be easier just to go ahead, since it's already a common denominator, to go ahead and add those together. So 4x and 6 will not mix because one's a number and another is a variable, but we're still going to get over 2x. Now we need to make sure that we remember to factor, so we can't just say like 4x over 2x and cancel that out to be 2. We need to factor out the numerator because we are adding that plus 6, so we can factor a 2, which is going to leave us with 2x plus 3, and then we have a 2x in the bottom. And now we have a common factor of 2 that we can cancel out or reduce to 1, and we're left with 2x plus 3 over x. Can't do any more factoring or any simplifying because we can't factor the numerator, so that would be our final answer. Kind of similar to what we did with subtraction earlier. We're going to distribute the negative, so we're going to say 4x plus 11, minus x minus 2, all over that common denominator of 3x squared plus 9x. Okay, we want to combine like terms up top, so we're going to get 3x plus 9 over 3x squared plus 9x. We want to factor out a 3 up top, so we get x plus 3, and then we want to factor a 3x out in the bottom, and we get x plus 3. Once we get this, we can see that we have a common factor of 3, and then we have a common factor of x plus 3 and x plus 3. Make sure that when we are canceling those, the true terminology is reducing to 1. So then we're going to result with a 1 up top because there's nothing left over x. And that would be my final answer. Okay. Moving forward, we need to know when we don't have a common denominator, what we want to do. And so we have 3 over 5x squared plus x plus 7 over 15x cubed. So we need to recognize that between those two, we kind of always have to build up. We can't build down, so we want to build up. So we would say, how do we build 5 to be 15? So we can build 5 to be 15 because our common denominator is 15x cubed by multiplying this by 3. Whatever we do to the bottom, we have to do to the top. And then we have to build up x squared to be x cubed, so we'd have to multiply it by an x as well. Okay, so we have 3x times 3 is 9x over 15x cubed plus x plus 7 over 15x cubed. And from there, now we can combine like terms up top. So we can combine those to be 10x plus 7 over 15x cubed. Now looking at this, up top we need to be able to factor the numerator, and 10x plus 7, 7's prime, so we can't factor that with 10x. So we are not able to factor this any further, and this would be our final answer. Okay. The one key thing we want to make sure that we do is we need to make sure that we multiply this out first before we do any adding or subtracting. So make sure that you're always doing that, which will make a little bit more sense as to why in the next problem. So we have 12 over x plus 2 plus 4x over x minus 3. And so we want to find a common denominator. So between x plus 2, that is one whole factor. We can't do any factoring with that. We have x minus 3. So whenever you have something like this, we want to say that the easiest way is to multiply by the other denominator. So we're going to multiply this left rational expression by x minus 3 on top and bottom. And this right side we're going to multiply by x plus 2. So if we do that, we need to distribute. So we're going to distribute this 12 into both. So we're going to say 12x minus 36. This is the part that's highlighted on the left side. We need to make sure we multiply that out first. But we do not need to multiply the denominator, okay, because we would end up having to factor it later anyway. So we don't have to FOIL that out. And then we're going to have plus. We're going to distribute this. So we're going to get 4x squared plus 8x over, again, we don't need to FOIL that in the denominator. Okay, combining like terms up top, we have a 4x squared, 12x and 8x make 20x, minus 36 over x minus 3 and x plus 2. Now you're going to want to always factor these as much as possible. So that's why we did not distribute the denominator, just because we would end up factoring that back together. So factoring the numerator, we can take a 4 out. All over x minus 3, x plus 2 is already factored. So we do not have anything in the numerator now that multiplies to negative 9 and adds to 5. So we cannot factor that any further. We don't have any common factors. So there's no factors of x minus 3 or x plus 2 in the top. So this would be our final answer. So you need to make sure that when we don't have common denominators, that you are multiplying by those. And if you have a binomial term, the easiest way is to multiply by the other denominator. So I hope this helps you with adding and subtracting rational expressions.